Welcome to solverfy.
Alrighty, so we are trying to do an algorithm that'll determine whether a function on a finite set is one-to-one. So let's recall what it means to be one-to-one. And to be one-to-one means that for any two inputs of a function, so since we are working with a finite set, we'd say like maybe AI and possibly AJ, right? So if AI does not equal AJ, so we should stipulate that. If we have two different inputs, then a function is one-to-one if the outputs are not the same, right? So if they were the same, that's going to look like, if this is AI and this is AJ, but we have the same value, that's going to be sort of your hyperbolas, right? If you can draw a horizontal line and get two values that intersect, we are not one-to-one. Something that is one-to-one might look more like this, right? So you can draw your horizontal line, and no matter what value you choose, you are going to get a different output from the function. So that's what we're trying to determine, and so we can create our algorithm, call it one-to-one, and the input, is going to be our integer list. These are our input integers that we would put into our functions, a1 to an, and n should be greater than or equal to 1. It could just be one element, right? X is equal to 4 is a function that's perfectly well defined. We also have our output list. And so this is sort of what f of a1 or f of a2 is going to be equal to something in this list. Okay, also integers. And with m also being greater than or equal to 1. And f is our function. All right, so this is sort of the space we're working in. Of course, the input, depending on what your function is, you may not actually need to be inputting this other list. So that'll depend. And we'll start with a sort of a checking variable. And we'll just set it equal to true. All right, and so then we'll say, well, for I from 1 to n, so this is the entire space, and for j, also running from the entire input space, okay, we want to say, well, if we have an AI that does not equal AJ, so this is how we're making sure that our two inputs are different. However, if these two things are not the same, but the integer that it maps to, right, so f of AI will be equal to one of these b integers, and f of AJ will also be equal to something on there. If this holds, and this could also really be written as, equaling something in the b's, but let's not overcomplicate it. Then we can reset our check. So initially we were sort of assuming that it is one-to-one, but now we're going to say, you know what, it's not. So we're going to say our check. Instead, let's set that equal to false. Okay, and then we just want to return our check. So if it turns out it goes through this whole list and never has a problem with the outputs, then it'll return true that it is one-to-one. And if at some point it finds out that it's not one-to-one, it will return a false for us.